All right, example 4, we have a dynamite blast propels a heavy rock straight up with a velocity of 160 feet per second. It reaches a height of s of t, which is 160 t minus 16 t squared after t seconds. So what this asks us to do is find the velocity and acceleration functions. The way we find velocity and acceleration functions is by using our derivative. Okay, so velocity, so v of t, is really just equal to s prime of t. So finding the derivative of our velocity function. Finding the derivative of our original function gets us our velocity function. So if I take this derivative, I would have 160 minus 32t. That's my velocity function. Then to go ahead and find my acceleration function, a of t, that's our second derivative. Okay, so what it is taking the derivative of my velocity. Or you guys can say it's the second derivative of your original. So the way I do that is I take the derivative of this, which gives me negative 32. Okay, so that is how you find your velocity and acceleration. You just got to remember, it's always position. The derivative of position is velocity. And then the derivative of velocity is acceleration. So I recommend just remembering position, velocity, acceleration in that order. Okay. And then B says, find the acceleration of the rock when the velocity is equal to 0. Okay, so this is actually asking us to do two things. Find the acceleration of the rock when the velocity is 0. Okay, so my velocity is v of t, and is means equals 0. So I need to take my velocity function and set it equal to 0. So remembering my velocity function from the other side, or just retaking the derivative of this, I would have 160 minus 32t. Then I would set it equal to 0. And I would solve for t. Okay, so I'm going to add 32t to the other side. I like to keep things positive if I can. And then divide both sides by 32. So 160 divided by 32, I do believe is 5. And this would be seconds. So this answers part of my question. Okay, it says we need to find the acceleration of the rock when the velocity is 0. I now know when my velocity is 0. It's when t equals 5 seconds. Okay, now I got to find acceleration. So a of t, getting my equation from before, is negative 32. So what I would do is plug in 5. In this case, if I plug in 5, there's no values to plug it in because acceleration in this case is constant. So my acceleration at t equals 5 is negative 32, and I would label it feet per second squared. So that'd be my answer. One thing I do want to point out is, what if your acceleration was negative 32t? Okay. If you had a variable on it, you guys would actually have to multiply it out. Negative 32 times 5, which should get you negative 160. Okay. But this one didn't. But just so to be aware, it's not always going to be a constant. There is chances where you might actually have to plug it in. So that is it for our motion problems. Here's your homework. It's off of 2 different pages, so just be careful. This is from section 3.1. And then this is from section 3.2. So what I want to point out to you guys is in 3.1, you did the power rule. So if I have like 2x to the 5th, those are the type of problems you would have in there. Okay, so you'd bring the 2 down, so your derivative would equal 10x to the 4th. So those problems you'll be able to do the power rule on. That's because it's from section 3.1. Section 3.2, that is where you guys did product and quotient rule. So you'll have to probably do product and quotient rule in this section. Okay, so just as a heads up. Otherwise, that is it for our applications of derivatives.